we are discussing about OR gate in detail with examples. Yesterday the basic idea is only given. Today's little bit analysis with examples. OR gate symbolize logic addition. Logic addition of logic addition by using symbolizes according to Boolean algebra or gate performance logic addition. Its truth table can be written as 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1. Purposely I explained here plus, but not it is a plus, it is a OR. 0 or 0 is equal to, the output is 0, 0 or 1 is equal to 1, 1 or 0 is equal to 1, 1 or 1 is equal to 0 is explained in the first class. It must be clearly understood that plus sign in Boolean algebra, what is Boolean algebra I will explain later. Now plus sign in Boolean algebra does not stand for the addition as understood in the ordinary or numerical algebra. Numerical algebra 1 plus 1 is equal to 2, but 1 plus 1 is equal to 10, binary operation. Now giving the plus sign in Boolean algebra does not stand for the addition is as understood in the ordinary numerical algebra. In symbolic logic, the plus sign indicates OR operation, whose rules are already given. In logic algebra, A plus A or B is equal to Y, or I am giving here X. Means that if A is true or B is true, true means 1, false means 0. A is true or B is true, then X will be true. It does not mean that the sum of the A and B equals to X. In other symbol we are using plus sign for U and B. U and B. Hence the above operation could be written as A union B, A or B is equal to X, or A B is equal to X. The meaning of the last three additions, what the meaning? Meaning of the last three additions, that output is 1 when either A or B or both are 1. That means yesterday first class I given that if only other parts 1 0 0 1 and other true or false, it will be equal to 1. Similarly here, the meaning of that last three logic addition is that output is 1 or high or true when either A or B or both are true. The first addition implies that the output is false or 0 only when both inputs are false or 0. The meaning of the plus sign often becomes clear from the context as shown. 1 plus 1, 1 plus I given 1 plus 1 is equal to 2 is arithmetic sum, algebraic sum. But 1 plus 1 is equal to 10, the binary sum, binary addition. And 1 plus 1 is OR addition. It is OR addition. We can put the above OR laws in more general terms with figure. I am giving here figure. 1 plus 1 is equal to 1. That means in general terms, here A is equal to the input are A is equal to 1 or 0. Then output must be when A plus 1 is equal to 1, when A plus 0 is equal to A, when both inputs are is equal to A. That means it is high. In this case, A is equal to 1, A is equal to 1, both inputs are high, the output must be high. As we know, A can be two values. A can be two values, 0 and 1. Then 0 or 1 or means 0 plus 1 means 0 plus, that is 0 or 1 is equal to, think 0 or 1 is equal to, you can think what will be the answer. When A is equal to 1, then the above expression 1 plus 1 is 1. Hence, we find that interpretive of the value A, and this is 1. Next, A plus 1 is equal to 1. A or 0 is equal to plus means, I am using plus means, or it is always or. A or 0 is equal to A. If A is equal to 0, then 0 plus 0 is equal to 0, must be equal to 0. That means A is equal to 0 means 0 or 0 must be equal to 0. Both is low, output is low. That is the meaning. The output is low, which correct is in this, both are 0 is equal to 0. Both are 0 is equal to 0. Then here it is A is equal to 1. What will be the output? Think. Next. Okay, it is always 1. Next, I am giving another concept. Now I am giving like this. Only one input I am giving. In that case, A is 0 means what will be the output? Then A is equal to 1, other case A is equal to 1, what will be the output? Then A plus A is equal to what is the output? When A is equal to 0, output is 0. Then A is equal to 1, output is 1. When A set to 1, the output is 1. Because 1 or 1 is equal to 1. Well, that is 1 plus 1 with the 3 inputs. 3 input OR gate, that means inclusive OR gate. That is the inclusive OR gate, 3 input OR gate. The electronic symbol for 3 input inclusive OR gate is shown here, as is usual in logic algebra. The inputs A, B, C as well as the output X can be can have only one of the two values, 0 or 1. We can see the truth table. The number of rows in the table is 2 raised to 3. That is A, B, C, X. 2 raised to 3. 1, 2, 3, 4, 5, 6, 7, 8. That is 2 raised to 3 is equal to 8. This very important point. There are 8 ways of combining the 3 inputs. In general, the number of horizontal rows is 2 raised to n, where n is the number of inputs. The horizontal row is 2 raised to, now here it is 3. It is 8 rows, 3 inputs. Where n is equal to 8, 2 raised to 8, like that it is coming. That is the meaning of that definition. In first column A, the logic values alternate between 0 and 1 every 4 rows twice. The second input B alternates between 0 and 1 every rows 4 times. The third input C, 0 and 1 every rows 8 times. That is the meaning. The truth table is symbolized by the equation A or B or C is equal to X, which means that X is 1 when either A or B or C is 1, or all are 1. Alternatively, X is true when A or B or C is true, all are true. Okay, this is the 3 input, and the symbol is shown here. And now I am going to explain the AND gate. This is AND gate logic symbol. Here the input AB, this must be C. It is very simple way to explain with this diagram. If both the switches are only, then lamp will only bright. If alternatively it is off, means output will be low or 0. This is the meaning of this circuit, simple logic. The electronic or logic symbol for 2 input AND gate is equivalent switching device, also explained here. It is worth reminding the readers or viewers once again that the 3 variables ABC can be value either 0 or 1. The logic operations, the AND gate gives an output only when all inputs are high or present or 1. The second logic is the AND gate has one output when both A and B are 1. Hence, this gate is an all or nothing gate whose output occurs only when all inputs are present. When all inputs are present, then only is the lamp bright. This is 1, this is 1, means this must be 1. 1 0 0, 0 1 0, whatever may be. All the inputs must be high, then only output will be high. That is the AND gate. Now here the explanation is giving like this: A and B is equal to 0. Note that dot sign for AND. A and B is equal to 0. And the third logic is, in true or false terminology, the output of an AND gate will true only all the inputs are true. Okay? The AND gate works Boolean algebra. A cross B is equal to X, or A dot B is equal to X, or A B is equal to X. A cross B is equal to X, A dot B is equal to X, A B is equal to X. It is a logic multiplication. It is different from the arithmetic multiplication. Often the sign x here is replaced by a dot, which itself is generally omitted and shown above. Suppose we are giving like that. The dot must be, sometimes it is omitted. Therefore, avoiding that confusion, the logical meaning of this above equation, output x is 1 only when both A and B are high. Then what will be the truth table for 2 input? 0 0 0, 0 1 0, 1 0 0, 1 1 1. A, B, C, 0 0 0, 0 1 0, 1 0 0, 1 1 1. This is the simple way of a truth table. Okay. Then we can see the next. Next, see, in general, we can put the laws of Boolean multiplication in the following. A and 1 is equal to 1. A and 1 is equal to 1. A is equal to A. A and 0 is equal to 0. And A is not A square, not A square. A square, not, don't mean that A square. Then the discussion, A dot 1 is equal to A. A dot 1 is equal to A. First discussion. Then 0 dot 1 is equal to 0. 0 dot 1 is equal to 0. A dot 1 is equal to A. A dot 1 is equal to A. Here a dot is there. Then 0 dot 1 is equal to 0. When A is equal to 1, output will be thick. 1 dot 1 is equal to 1. It is seen that in each cases the output will have the same value of A. Now the NOT gates. Logic symbol is this. Here is a bubble. Mean that ulta, opposite. What are we giving? Its opposite value will give. It is so called because of the output is not the same as the input. It is also called inverter, not the power inverter. It is a logic inverter. Because it inverts the input signal. It has one input, one output. All it does is to invert or complement. The input is given in the truth table. 0, 1, 1, 0. We can see what is output. This is A, this is B. When we are giving 0, output will be 1. When we are giving input, output will be 0. Just opposite. The schematic symbol for the inversion is a small circle, which means the logical symbol for inversion or negation of complementation is a bar. The function of the indicates the opposite state. Therefore, B, output B is equal to A bar. The output B is equal to A bar. Okay, the opposite state. And the only one input, one output. Whatever we are giving in the NOT gate, the output will be just opposite. 0, 1 or 1, 0. Or symbolically representation, the output B is equal to A bar. Output B is equal to A bar. Next is the NOT operation. NOT. A NOT. What is the NOT operation? We can see NOT operation 2. 2. Here A is given. The output must be A bar. Is this the input of the second NOT? That is A bar. Here it is A double bar is equal to A. Then what will we are giving 0 here? Think, what will we are giving 0 here? It is 1. Output will be 0. Bar we are giving 1. Here it is 0. Then output will be 1. Okay. This is the end of this part. Next we are giving the examples. Because of this video having long length, that is next part I am explaining with the examples. Thank you.